Hello, everyone. Hopefully today's treating you well. This is coming out a little late. Sorry about that. Hopefully you'll be able to look at it before our 1 o'clock meeting, but if you didn't get a chance, I apologize about that. I'll try to have them up the night before from here on out. So what we're talking about today is we're going to take a look at the next part of 3.4. So just really quick, as I share my screen, we're just going to talk about 3.4 day 1 real quick. So just kind of recap. Life's been crazy. You probably haven't remembered any of this, or maybe you were not there the day that we talked about it. So just kind of give like a quick run through on what 3.4 day 1 was. It's all filled out here. The big takeaway I want to talk about is the 65, 95, 99.7 rule. Here we go. I can see everything. 68% of observations fall 1 standard deviation of the mean. So on either side of the mean, we'll take a look at what that looks like with the density curve here in a second. Remember that normal curves are symmetric. So 95% of observations fall within 2 standard deviations of the mean, and 99.7% of observations fall within 3 standard deviations of the mean. So that's the big important part right there, is that 65, 95, 99.7 rule. So if we have this normal distribution, you can see here, 68% is from here to here, 1 standard deviation on either side of the mean, which is 0 standard deviations away. Oops. And then 2 standard deviations away on either side. So from here to here, that's 95% of the area. And then 3 away from here to here is 99.7. So that's the big takeaway from that section there. Then I'll put this up, pause it, take a look at it, look at our work. If you were gone, nice thing about a video lecture is that you can pause. So you can go through that, and you can go through this problem here. Okay. So that was just a real quick run through of 3.4 day 1. Day 2 is going to use what's called the z-score table. So I'm going to share again with you. Exit that. I have put this on Powerschool. This is something that you will have available for you. You're going to need it. So print it out, just have that file available. But here's a table of standard normal probabilities for negative and positive z-scores. So again, that z-score is basically how many standard deviations away from the mean are we. So if we have a z-score of 1, we're 1 standard deviation away from the mean. So then what that means is then what's the probability that something is less than 1 standard deviation away from the mean? So all the space underneath the curve less than 1 z-score. This is what our chart tells us. So 1.00, 0.8413% of the values are less than 1 z-score or 1 standard deviation away. That's what this tells you. It's talking about percentiles, talking about probabilities, so on. So let's take a look at how this can make a little bit more sense. If something is 0 z-scores away, it means it is the mean. If it's 0 z-scores, if it's 0 standard deviations away, it is the mean. If it's symmetric, the mean would be half. Well, then that makes sense that this probability then is 0.5 or half of 1. Or if you look down here, we're getting further and further away from the mean. We're 3.4 standard deviations away. 3.4, well then this would be 3.49, 0.99998. We're really close to 100% of the data. which makes sense. 99.7% of the data is between 3 standard deviations. So what we did in 3-4 day 1 is between 2 standard deviations. From here to here. All this is from at 1 standard deviation, all the values to the left of it. Now, I don't know, this video is going to flip when I share this, but pretend like this is left, all the values to the left of it. You can see it on the screen here. Now, these are just negative z-scores. The same idea, though. 1 standard deviation less than the mean. How many values are 1 standard deviation less than mean? 0.1587. So we're going to refer to this a lot as we look through this section here in this 3-4 day 2. So let's take a look at the notes for that. I'll move my face. Okay, so this is just what I talked about here, finding area using the table. So find the z-score using the side and top of the table. So for example, if I have z of negative 1.78, find 1.7 on the side and 0.08 on the top. Where the row and the column cross is the area to the left of that z-score. So how many values are less than negative 1.78? So let's look at our z-score table again then. Negative 1.78. So there's negative, let's see, right? We'll highlight that better. So there's negative 1.7, 0.8. So in order to find negative 1.78, where those two meet, that's the amount of values that are less than negative 1.78 z-scores. So how many values are less than 1.78 z-scores less than the mean? This area right here. So not a lot. 0.0378, that's only 0.375. That's only 3.75% of the values are less than that. Because again, remember, from 1 z-score to 1 z-score on either side is 68% of the data. From 2 is 95%. So there's not a lot of values that are going to be less than 1 z-score or 2 z-scores even. So if we did 2, for example, look at that. It's only 0.228. So let's go back to our notes. So this table tells us all the values to the left. If something asks you how many values are greater than 2 z-scores away, or the area to the right, you subtract the table area, so what the table tells us, from 1. So 1 minus table area. If you want the area between 2 values, which is what we did before in 3-4 day 1, but that only is very, very, very specific z-scores. Negative 1 to 1, negative 2 to 2, negative 3 to 3. Those very specific scores only fit in that 68, 95, 99.7% rule. If we're talking about the z-score from negative 1.78 to 2, that's not going to be 95%. It's going to be close, but it's not going to be 95%. It's going to be really, really close. So what we do instead is, if we want to find the area between 2 values, take the larger z-score minus the smaller z-score in their table area. So not the z-score itself. So don't do, we wanted to find the z-score between 2 and negative 1.78. Don't subtract those two from each other. It's their table areas. What does the inside part of the table tell us for those z-scores? That's what we want to find, the area between those 2 values. So let's look at some examples. The area less than 1.3 standard deviations. So the z-score is 1.32. So we go back and we look at our table for 1.32. So again, using my highlighter, this is the negative side. I have a positive 1.32, so I need to go to the positive side. So I find 1.3, I find 0.2. Where do they meet? At 0.9066. So area less than 1.32 standard deviations. Well, then our area is 0.9066. Table told us that. Area greater than negative 1.59. So our z-score, negative 1.59. We'll have to look at our table to figure out what that is. I have no idea. But once we find that table value, it's 1 minus the table value in order to find greater, because the table tells you less than, tells you to the left of it. If I want to find greater, I need to do 1 minus that. So 1 minus, let's look at negative 1.59 on our table. So negative, I need to go to the negative side. Negative 1.5. And then 0.9 is over here. So where do those two meet? Right there. So it's 1 minus, so it's not, the answer is not 0.0559. That's the table tells us to the left of it is. I want to know greater than negative 1.59. And we end up with 0.9441. So if we're talking about something specific, how many observations are greater than 1.59 standard deviations away? It's 94.41%. This value as a percentage. Okay, area between. So it's this table value, the table value of 1.32 minus table value of negative 1.59. Again, it's not 1.32 minus 1.59. It's the table value, which we already know. Here it's 0.9066 minus this table value, which is this right here, not this, not the 0.9441. This is the table value. That's why we subtracted it from 1 for greater. Here we're just finding the two between. And so you end up the area between the two. What percentage of values are between those two? 0.8507. I did the subtraction there. I did it ahead of time. Okay, your next one. What z-score is the 35th percentile? Okay, so 35th percentile is saying there are 0.35 area to the left of this. So we're actually going to work backwards. So I'm going to clear all this ink, clear all the highlighter. And in this purpley color, I want to find 0.35 on the inside of the table. I want to get as close as I can to 0.35. There's 0.34, there's 0.38. Okay, so we need to get closer. Well, we're getting smaller here, so we need to look over here. Okay. Well, there's 0.3520, and there is 0.3483. So right in the middle of those two is 0.35. Well, let's figure out what those two z-scores are. Negative 0.3, What's the top value? 8 or negative 0.39. Well, it's somewhere in the middle of those. So if we're not exact or we're not really close to the percentile we want, we're actually going to find the average of those two z-scores. So the two z-scores we found that were close were negative 0.39 and negative 0.38. So I'm going to average those. Negative 0.385 as the z-score is the 35th percentile. What z-score has 14% of all observations greater than it? Greater than it. So that means 14% are bigger than it. How much are less than it? Or the percentile? Well, we would do 100 minus 14 and get 86th percentile. Or a table value of 0.86. So again, we want to get as close as we can on our table. To 0.86. Oh, there's 0.4, 0.87. Okay, we're really close. 0.86, 43, 0.86. Okay. This is 0.8599. You cannot get any closer to 0.86 than that. So I'm going to say that that's good. I don't have to average. So I look over here. It's 1.0, 1.08. Left and up. Where do they meet? Right there. So it's z-score 1.08 because it's basically 86 right there. It's basically 0.86. You can't get any closer than that. So I'm not going to average them. I'm good right there. Okay. So use table A to find the proportion of observations from a standard normal distribution that fall in each of the following regions. In each case, sketch a standard normal curve and shade the area region represented. I'm not gonna worry about sketching the standard normal curve. I'll do it, whatever. Nothing but time. So Z is less than 1.39. So area to the left of 1.39. That's pretty good one. So there's 0, 1, it's about right here. Area to the left because it's less than. That's what our table tells us. So we just go back, look at our table. I'm going to clear the ink here. Let's go back and look at our table. Positive 1.39. 1.3. 0.9. Where do they meet? Right there. 0.9177. So the area less than 1.39. 0.9177. Greater than. So then remember, this is 1 minus the table value. So let's go find our table value for negative 2.15. Negative, so go to the other side. Negative 2.1. 0.5. So that right there. So it's 1 minus that table value of 0.0158. Or 0.9842. Number 3, negative 0.56 less than Z. less than 1.81. This is asking, like number 3 here, area between those two. So I find table value for this one. So table value of 1.81 minus table value of negative 0.56. So let's find those two values. Negative, so we're on this side, negative 0.5, 0.6, where those two meet, right there. So 0.2877 is our second value, actually, 0.2877. So now I need to find 1.81. 1.801, 0.9649, 9649. Two times I remember and I still forgot. 9649. Okay. Like a 6, but upside down. 9649. Subtract the 2. 0.677. Okay, 20th percentile. 20th percentile would be a table value of 0.2. So I find 0.20 on my table. Clear the ink. Positive value, so we're going to be on the positive side. 0.2. Oops. Move the whole thing highlighter. There we go. 0.2. Oh, no. We're finding the value inside, so sorry, not the z-score. So we want to find 0.2 in here in the middle. 0.219, so we're getting closer. We're getting further away. 0.2090, 6133. This is really, really close, so I'm going to save that right there. Whatever that z-score is. Negative 0.84. Because you can't get much closer than 0.005 to 0.20. So that z-score then, negative 0.84. 45% of all observations are greater than z. Greater than, we want to find what percentile that is then. That's the 55th percentile. Or a table value of 0.55. So again, we're going to look at our table. We've got to find 0.55. Well, I know 0.5 is at 0, so it'll be on the positive side. 0.551 and 0.5478. Okay, so these are pretty far from where we want, so we're actually going to average those two right in between. So it's going to be the average of 0.12 and 0.13. And you get 0.125 as the z-score. Okay. So that's in general what you can do with that. On the back side of your notes, if you had printed them out or if you're just following along on your computer, We can use these z-scores to answer specific questions. So following the rules that we follow to solve problems involving normal distributions, just problems that we've done in general, these 4 ideas: state, plan, do, conclude. So state, express the problem in terms of the observed variable x. What is it that we're dealing with? Plan, draw a picture of the distribution and shade the area of interest under the curve. So you can visualize where is this going to land on our table. And then do, perform calculations. Standardize x to restate the problem in terms of normal distributions variable z. So you need to find the z-score, basically, which we know how to do. We did that last chapter. I'll show you how to do that again on here. And then use table A. That's that table we've been using. In fact, the total area under the curve is 1 to find the required area. So what we've been doing up above. Once we find that z-score, it's everything that we just did. Then write your conclusion in context of the problem. So let's look at our first example here. When Tiger Woods hits his driver, the distance the ball travels follow a normal distribution with a mean of 304. Okay, there's your mean. And a standard deviation of 8 yards. What percent of Tiger's drives travel at least 290 yards? So that means they can be bigger than that. Okay, so let's state here. That's our first plan, is to state. So x is the distance of our drive. We want to find, so state, plan, oh, sorry, we want, so part of state, sorry, distance ball travels. We want to find greater than, because at least tells it that 290 is the smallest, greater than or equal to 290. So plan, our plan is to find the z-score to the right of 290. So our first step is to find that z-score. Well, it's our value, 290, minus the mean over the standard deviation. And you end up with negative 1.75 for the z-score. But this is the, okay, so we found our z-score. We need to find our table value. I'll do that in a second. But it's greater than 290. If I just found the table value, that would tell us less than 290 or 1.75 standard deviations less than the mean. So I want to find 1 minus the table value. So let's look at our table and find our table value. So let's clear all that. Okay, so our, see, it even happens when I'm recording. My voice still cracks. Just a touch for you all so you feel like this is no different than a regular lecture, like I was right in front of you. Negative 1.75. So find that table value, 0.0401. So it's 1 minus 0.0401 or 0.9599. So 4, conclude, write that as a percentage. 96% of Tiger's drives are at least 290 yards. %96 of Tigers' drives are at least 290 yards. That's what we found there. What percentage of Tigers' drives travel between 305 and 325? So I need to go full screen here so I get all of the space that I need. Nope. There we go. So we need to find, so same idea, state and plan are the same, just a z-score between 305 and 325. So z is equal to 305 minus 304 over 8, or 0.125. So small z-score, it's barely above the mean. Z is equal to 325 minus 304 over 8 equals 2.625. Okay, so pretty big z-score there. So we need to find the table values for each of those. So let's do that. Table value for 0.125, we need to be on the positive side. 0.1, 2. We don't have a 0.25, so I'm going to round it up to 0.3. You get 0.5517. We'll just remember that, and I'll come back to it later. And then 2.625. We don't have a 0.25 up here, so we'll round it again. 2.6. 25 will become 0.3. So there's that table value. So this table value minus that table value would get you the area between those two, or what percentage of Tiger Woods' drives fall between the two. So that table value was 0.5517. This was 0.9957. So subtract the two. 0.9957 minus 0.5517. And I rounded it to get 0.44. So that means 44% of Tigers' drives are between 305 and 325. Okay, one last problem to take a look at here. For freshman male students, the distribution of blood cholesterol is approximately normal, so it follows these patterns. We can use these charts. With mean 170 milligrams of cholesterol, so there's our mean per deciliter, and standard deviation of 30 milligrams per deciliter. What is the first quartile of the distribution of blood cholesterol? So that means if I'm looking at my normal curve, again, pretty good one, there's about a quarter of it. So that means the table value is actually, if it's first quartile, that's the 25th percentile. So that means the table value is 0.25. So what's the z-score? So again, we're working backwards, working from the inside of the table and working out. So 0.25, it's probably gonna be in the negative area. So we need to find 0.24. Okay, we want to get a little bigger than that. 0.2578, smaller, smaller, smaller. Okay. So it's going to be somewhere between those two at negative 0.67 and 8. So the z-score is equal to negative 0.67 plus negative 0.68 divided by 2. We get the z-score is negative 0.675. So we want to figure out what value has a z-score of that. We've done that before. We did that last chapter, working backwards from here. So before we didn't know the standard deviation, we knew the values. This actually is going to be a little easier. Multiply both sides by 30, and then add 170 to both sides, and you get that the x would end up being 149.75 milligrams per deciliter. Hopefully that algebra is fine. Just multiply by 30, added by 170. I hope we're okay at solving something like that at this point. So yeah, so I'll stop sharing my screen here. So there's 3-4, day 2. That's the last section of this chapter. Where do we go from here? We're gonna figure that out. But just to start, I have that assignment. It's already up on Powerschool. Again, sorry, this is going to be up late. So if you don't come to the 1 o'clock meeting because you haven't seen this yet, that makes sense. But the next thing is that we're going to review 3-4 a little bit, keep practicing this. So I might just have a few practice problems I'm going through that I'll post. And then eventually we're going to do the first take-home quiz that I'm going to grade that you'll send in, hopefully in Powerschool. But yeah, hopefully this structure is helpful for you. So I'll see you at 1.